Every time the Earth shakes, it releases a massive burst of energy. But here's the shocking truth. The shaking we feel on the surface is just the tip of the iceberg. So where does the rest of that energy go? Until now, scientists had no way of fully measuring it, but geologists at MIT just cracked the code, with earthquakes small enough to fit in the palm of your hand. In their lab, researchers created miniature earthquakes, lab quakes, using small slabs of granite, the same rock found deep in Earth's crust where real earthquakes are born. By squeezing these rocks under intense pressure, they triggered tiny seismic slips and captured every fraction of energy released. For the first time, they measured the full energy budget of an earthquake, and the results are mind-blowing. Only about 10% of a quake's energy goes into shaking the ground. Less than 1% breaks apart rock, but a staggering 80% vanishes into heat. In microseconds, temperatures at the fault spike to over 1,200 degrees Celsius, hot enough to melt solid rock into liquid glass. Scientists actually saw the rock transformed, from solid granite into tiny pockets of molten glass, before cooling back down almost instantly. But here's the kicker. How this energy splits depends on the rock's past. The deformation history, the scars left by ancient tectonic shifts, determines whether future quakes will release more shaking or more heat. In other words, the memory of the rocks themselves may hold the key to predicting how destructive the next quake could be. These lab quakes are tiny, but they offer one of the most complete views of earthquake physics ever achieved, a window into processes that happen miles below our feet, at scales too vast to study directly. And with this knowledge, scientists may finally refine earthquake models, improving predictions, and helping us prepare for nature's most violent forces. Subscribe to LG News and discover the science that reveals the hidden power of our planet.